Good morning, dear students. My name is Ferhan Mazher, and the subject today we are studying is Cambridge O-Levels Physics 5054. Today in this video, we are going to work on a new topic which is added into the syllabus. The name of the topic is Momentum, Impulse, and Resultant Force. You see, this topic, this is the first time this topic will be assessed in the exams. So we don't have MCQs related to this topic. So in this video, we are going to attempt the MCQs which were available in the IGCSE Extended Physics 0625 course. And these MCQs I have taken from March 2023 up to 2018 papers. So I have collected all the questions which were related with the momentum, and I'm going to present to you the solution of those MCQ questions. So let's start and let's see what happens. Okay, so here we have the first question coming up on your screen. So this question is from the February-March 2018 2 paper, and he says a stone of mass 0.12 kg is fired from a catapult, and the velocity of the stone changes from 0 to 5 meters per second in 0.60 seconds. What is the average resultant force acting on the stone while it is being fired? Okay, so you know the resultant force according to the momentum, and the resultant force is the rate of change of the momentum. That is, we have the formula for that, and the formula is F is equals to mv minus mu divided by t, where mv is the final momentum minus the initial momentum, and the whole thing divided by t. So the mass is 0.12 kg, the final velocity is 5 meters per second, and the initial velocity is 0. The time for this change is 0.6 seconds. So just put those values there, 0.12 multiply 5 minus 0.12 multiply 0 equals to divided by 0.6. You will get 1 Newton. So 1 Newton is the answer. So let's see. Let's see what happens. Okay, so I think this is the answer. Okay, so let's see. Okay, so question number 1A is the answer. Question number 1A is the answer, sir. So this is how this is done. Okay, so now we are on the February-March 2019 2 paper. It's question number 10. He says a constant force acts on a body, causing the momentum of the body to increase. Which expression relates the force to the momentum and the time taken? You know, it's a very famous thing that the force is equals to the change in momentum divided by time taken. So this is A is your answer. So let's check. Okay, question number 10A is the right answer, sir. Question number 10-8 is the right answer. Okay, question number 10-8 is the right answer. Okay, so let's go back. A is the right answer. Okay. Then we have February-March 2019 2 question number 16. Gas molecules exert a pressure when they collide with the walls of a container. Which statement is correct? They experience a change in force which exerts a pressure equals to momentum multiply area on the walls. B option is they experience a change in force which exerts a pressure equals to momentum divided by area on the walls. They experience, C choices, they experience a change in momentum which exerts a pressure equals to force multiply area on the walls. The D option is they experience a change in momentum which exerts a pressure equals to force divided by area on the walls. I think the D is the option. Yeah, question number 16, D is the right option, sir. Question number 16, and I think D is the right option. Question number 16, D is the right option because the change in the momentum that will cause a force, and the force per unit area that will be equals to the pressure. Okay, so we are going to the next question. Okay, the next question is February, March 2020, 2-2 paper. Question number 10. An air pistol fires a pellet forwards. What is the motion of the air pistol? You see, whenever the pellet goes forward or the bullet goes forward, the pistol moves backward. So the air pistol moves backwards with the speed greater than the pellet. Okay, so another thing is important that when you fire a bullet, so the momentum of the bullet and the momentum of the pistol, they both are equal to each other. The direction is opposite, but they are in magnitude, they are equal. You see, the mass of the bullet is very small, and so its velocity is large. But because the mass of the pistol is large as compared to bullet, so its velocity is less. So the pistol will move backward, but with less speed. So the A option is the pistol moves backwards with the speed greater than the pellet. No. The air pistol moves backwards with the speed less than the pellet. Yes, it looks the answer. Okay. The air pistol moves forward with the speed. No, the air pistol do not move forward. The air pistol moves forward. No, the air pistol do not move in the forward direction. So we think question number 10, B answer. Yes, question number 10, the B is the right answer, sir. This was the question. Okay. B is the right answer. Okay. Now we have February, March 2021, 2-2 paper. He says a gas molecule strikes the wall of a container. The molecule rebounds with the same speed. So here you have that gas molecule and it collides with the wall. Here the gas molecules rebounds, and this is before hitting the wall, this is after hitting the wall. What happens to the kinetic energy and what happens to the momentum of the molecule? Okay, you see here the gas molecule is moving in the opposite direction after the collision. So it's the velocity sign has changed, direction has changed, but the magnitude of the velocity do not change. So we can say that the kinetic energy will not change, that will remain the same, but the momentum will change. He says, what happens to the kinetic energy? What happens to the momentum of the molecule? Yes, the kinetic energy stays the same because the velocity, its magnitude basically, do not change. Only the direction of the velocity changes. So the kinetic energy basically do not change, and the momentum changes. So I think the question here, C will be the right answer, I think. Question number 9, you can see, sir, C is the right answer. Okay, because this was the answer question. C is the right option. This is the marking scheme. Okay. So now we have February, March 2022, 2-2 paper, and it's question number 10. A resultant force of 500 Newton acts for 10 seconds on a car of mass 1000 kg. This causes the velocity of the car to double. What is the final velocity of the car? Okay, So we know the mass of the car, we know the resultant force, and we know the for how much time the resultant force acts on the car. And we know one thing, that the velocity has doubled. Before, if, for example, before the application of the velocity, if the velocity was v, then after the application of the velocity, for after 10 seconds, after the application of the force, I mean, the velocity will become 2v. So we will apply the formula that the resultant force is equals to the change in the momentum divided by time. So, okay. So the F is equals to mv minus mu divided by t. So suppose the mass is m and the velocity is, the initial velocity is x and the final velocity is 2x. So you will have F is equals to m into 2x minus m into x, and the whole thing divided by t. We know that the F resultant force is 500 Newton, and that is equals to 1000 multiplied 2x minus 1000 into x, the whole thing divided by 10. So it will be that 10 will come to the other side, it will multiply with the 500. So it will become 5000 equals to 2000x minus 1000x. So 5000 is equals to 1000x. So x will be equals to 5000 divided by 1000, that will be 5. The final velocity will be 2x. So it will be, the value of the x is 5. So it will be 2 into 5, and that will be 10. So the final velocity will be 10 meter per second. And this was their question. So the final velocity will be 10 meter per second. And I think B is the right option. Question number 10, this is the solution. Question number 10, I think B is the right answer, sir. So you can see question number 10, B is the right answer. So this was the question. This was the solution. And we know the B is the option. Okay. Now we have February, March 2022 to do paper. We are on the question number 12. At the time equals to 0, a cannonball is stationary inside a cannon. The cannonball is then fired from the cannon. At the time equals to t, the cannonball moves forwards and the cannon moves backward. Okay. What happens to the total kinetic energy and the total momentum of the cannon and the cannonball between time equals to 0 and the time equals to t? You see, in the first situation, when the cannonball is in the cannon, because the cannon is not moving, the cannonball is not moving, so its kinetic energy, the kinetic energy of the whole system, will be 0. So when the fire will take place, when the cannonball is fired, the cannonball starts moving, the cannon also moves backwards. So they both move, so they both will have the kinetic energy. So the system will have kinetic energy. So it means that the total energy, kinetic energy of the cannon and the cannonball will change. Before the fire, the kinetic energy will be 0, and after the fire, there will be some kinetic energy. Okay, the total momentum of the cannon and the cannonball, you see the cannon and the cannonball, they both have, after the fire, they both will have the same momentum, means the magnitude of the momentum will be same, but the direction of the momentum will be opposite to each other. So when you add their momentums, the momentum of the cannonball and the momentum of the cannon, the resultant will be 0. And so it means when the fire takes place, means cannonball is fired, the total momentum of the system is 0. And before the fire, because the cannonball is not moving, the cannon is not moving, and before the fire, the total momentum is 0, and after the fire, the total momentum is 0. So that means that the total momentum has not changed, but the total kinetic energy of the cannon and cannonball has changed. So I think the kinetic energy will change, and the total momentum will not change. So I think B is the right option, sir. That the kinetic energy will change and the momentum remains the same, and that is 0. Okay, so question number 12, B is the answer, sir. Question number 12, you can see on the marking scheme, B is the answer. This is the question, and B is the option. Okay, so we are going to the next, and that's February, March 2023, 2-2 paper. This is the latest paper we have. The momentum of a body is changed by a force acting on it for a period of time. Which action increases the change in momentum? You see, the change in the momentum increases if you increase the force, and if you decrease, you see, change in momentum is basically F multiplied T. Change in momentum is equals to F multiplied T. So A option is doubling the force and halving means half the time. So if you double the force and half the time, because the change in momentum is equals to F multiplied T. So if the F will double and the time will half, the result will be still the same. B option is doubling the force for the same time. Yes, here. You see, if you double the force and you keep the time of that force same, uh, so then the momentum will also become double. The change in momentum will become double. So halving both the force and the time, no. Halving the force and doubling the time, no. So if we double the force and keep the time same, you see the delta P. Delta P means change in the momentum. The delta P is equals to the resultant force and multiplied time. Okay, so this is the formula. So if you will double the force and keep the time same, the change in the momentum will also become double. So I think the B is the right option. It's simple mathematics. Question number 9, B is the option. Yes, you can see in the marking scheme that the 9, question number 9, B is the right answer. So this is the question, sir. B is the option. Okay. So we have May, June 2018 to 1 paper. Question number 9. Which expression gives the momentum of an object? You see, it's a very straightforward, simple question. The momentum of an object is mass multiply velocity. Mass is taken in kg normally, velocity is taken in meter per second. So we think question number 9, C is the right option. Momentum is equals to mass multiply velocity. Question number 9, C is the option. Question number 9, C is the option. Okay. May, June 2018 2-2 paper. So, question number 9. A car of mass 1000 kg traveling at 8 meter per second collides with a lorry of the mass 3000 kg that is traveling at 2 meter per second in the same direction. After colliding, the two vehicles stick together. What is their speed after the collision? So here we will use the uh, principle of momentum, and that says that the total momentum before the collision is equals to the total momentum after the collision. So M1 U1 plus M2 U2 will be equals to, because when the cars they stick together, so their total mass multiply V2. Okay, so M1 is 1000, its velocity is 8 plus 3000 multiplied 2 is equals to the total momentum when they will stick together will be 1000 plus 3000 into V2. V2 is the question. So you will have 8000 plus 6000 equals to 4000 V2, and you will have 14,000 equals to 4,000 V2. So the V2 will be equals to 14 divided by 4, and that will be 3.5 meter per second. 3.5 meter per second. So 3.5 meter per second, I think C is the right option, sir. This is the solution of that question. C is the option. Question number 9, C is the option. So our answer is right. Okay. May, June 2018, 2-3 paper. Question number 9. A visitor to a fairground throws a soft object of mass 0.12 kg at a coconut of mass 0.48 kg. The soft object stops moving when it hits the coconut. In order to dislodge the coconut, it must be made to move at 0.10 meter per second. What is the minimum speed with which the visitor should throw the soft object in order to dislodge the coconut? Okay, so here the soft object will collide with the coconut. So the momentum before the collision and momentum after the collision, they will remain same. Okay, momentum before the collision will be m1 u1 plus m2 u2. M1 is the mass of the soft object, and u1 is the velocity with which the soft object is moving, and m2 is the mass of the coconut. U2 is the initial velocity of the coconut, which is 0 because it was at rest. And then after the collision, so the soft object will stop moving, so its final velocity will be 0. The coconut's velocity will be at least 0.10 meter per second. So we have to find out what is the initial velocity of that soft object. So the momentum before the collision and momentum after the collision, they are equal to each other. So m1 u1 plus m2 u2 is equals to m1 v1 plus m2 v2. So 0.12, that's the soft object. 0.12 kg multiply x, we don't know what is its initial velocity, this is the question, plus 0.48 into 0, the coconut is at rest, is equals to 0.12 into 0 because the final velocity of that soft object is 0, and 0.48 into 0.1. So you will have 0.12x is equals to 0.048. So x will be equal to 0.048 divided by 0.12, and the x will be equal to 0.4 meter per second. So that means that the soft object must be at least at a velocity of 0.4 meter per second. So I think this is the answer. Question number 9, we think B is the answer. This is the solution. Question number 9, B is the right answer, sir. This is the solution, and this is that question. Okay, so we are going to the next question. Okay. We have May, June 2019 2-1 paper. Question number 9. A ball of mass 0.50 kg falls and hits the floor at 10 meter per second. It rebounds at a speed of 8 meter per second as shown. So before the collision, the ball is going downward, and suppose its velocity is negative, and negative means its direction is downward. You can take it as positive. So then when the ball will rebound and it will go in the upward direction, suppose that is positive, the direction of the velocity is positive. So that is 8 meter per second. Okay. So we know the mass of the ball, and the collision between the ball and the floor lasts for 0.50 seconds. What is the average force acting on the ball during the collision? So the average force acting on the ball during the collision, that can be found. F is equals to change in momentum divided by time. So very easily we can find out. Okay, here we have. So the change in momentum will be m1 v1 minus m1 u1, the whole thing divided by t. So the 0.5 multiply 8 minus 0.5 multiply with minus 10. Why I put negative with it? Because I told you that I am supposing that coming down is negative. And that's why I'm putting a negative sign with it. So the total momentum will be 4 plus 5, and that will be 9 divided by the total time, that is 0.5 seconds. So 9 divided by 0.5 seconds, that will be 18 Newton. So the resultant force will be 18 Newton. And every force acting on the ball during the collision, so it will be in the upward direction. The force acting on the ball will be 18 Newton in the upward direction. So we think C is the choice. Let's see. Question number 9, C is the choice. This is the solution, and this is that question. Okay. So now we have May, June 2019 2-2 paper. He says an object of mass 4 kg is moving with a velocity of 3 meters per second in a straight line. What is the momentum of the object? You see, we know the mass of the object, we know the velocity of the object, we can calculate the momentum. The momentum is equals to mv. The momentum will be equals to the mass is 4 kg, the velocity is 3 meters per second. So the momentum will be equals to 4 multiplied 3, and that will be 12 kg meter per second. 12 kg meter per second. So let's see what's the choice. 12 kg meter per second. And I think C is the answer. So let's check. Question number 9. C is the right answer, sir. Okay. We have May, June 2019 2-3 paper. Question number 9. How is momentum, which is small p, calculated in terms of the mass m of a body and its velocity v, and what type of quantity is the p, means momentum? You see, the momentum is mass multiplied velocity, and momentum is a vector quantity. It has direction. So I think the best option here is the B option, I think. Question number 9, B is the right answer, sir. This is the solution. May, June 2020 to 1 paper, question number 9. He says an object of mass 1.2 kg is moving with a velocity of 2 meters per second when it is acted on by a force of 4 Newton. The velocity of the object increases to 5 meters per second. For what period of time does the force act on the object? You see, the force is equals to change in the momentum divided by time. So time is the question. So very easily we can find out that. Here is the solution. F is equals to the change in the momentum m1 v1 minus m1 u1, and the whole thing divided by t. Here we will have 1.2 multiply 5 minus 1.2 into 2 divided by t, and the resultant force is 4. So 4 is equals to 6 minus 2.4, the whole thing divided by t. So the t will be equals to 3.6 divided by 4, and that will be 0.9 second. So 0.9 second, 0.9 second. Do we have that here? Yeah, 0.9. Question number 9A option. Question number 9A is the right option, sir. May, June 2020 2-2 paper. Question number 9, he says, an object is moving at positive 3.0 meter per second. A force acts on the object. After a time, the object is moving at minus 4 meter per second. So the object is now moving in the opposite direction. The mass of the object is 5 kg. What is the change in the momentum of the body? So the change in the momentum is change m1 v1 minus m1 u1, final momentum minus initial momentum. So 5 into minus 4 and minus 5 into 3. So it will be minus 20 minus 15, and that will be minus 35 kg meter per second. Minus 35 kg meter per second. Question number 9A is the right option, sir. This was the question. Okay. So we have May, June 2020, 2-3 paper. Question number 9. A ball falls vertically to the floor and rebounds vertically upwards just before it hits the floor. Its speed is 4 meters per second. As it rebounds, its speed is 3 meters per second. The mass of the ball is 5 kg. What is the change in the momentum of the ball? Okay, the change in the momentum will be, uh, final momentum minus initial momentum. And so suppose coming up is positive and going down is negative. Okay. So you will have M1 V1, that will be 0.5 into 3 minus M1 U1, that will be 0.5 into minus 4. So you will have 1.5 plus 2. So the change in the momentum will be 3.5 kg meter per second. Kg meter per second. Okay, so 3.5 kg meter per second, and that will be in the, because it's positive, so it will be in the upward direction. So I think question number 9D is the right option. Question number 9D is the right option. So here we have May, June 2021 2-1 paper. And it's question number 8. So May, June 2021 2-1 paper. Question number 8. A ball has a mass of 2 kg. The ball approaches a wall at a speed of 3 meters per second and rebounds at a speed of 1 meter per second. So suppose that going towards the wall is negative. So, and going away from the wall is positive. So what is the impulse on the wall? You know, the impulse is equals to change in momentum. Impulse is equals to change in momentum. So here we have impulse is equals to change in momentum. That is M1 V1 minus M1 U1. So V1 means the final velocity, U1 means the initial velocity. So 2 into 1 minus 2 into minus 3. So it will become 2 plus 6, and that will become 8 Newton second, or you can say kg meter per second. So Newton second. So because the change in the impulse is equal to the change in the momentum, and remember, impulse can also be found by the formula F multiply T. So we think 8 Newton second. So this is the choice. Question number 8 and D is the choice. Question number 8, D is the right choice. Now we have May, June 2021 2-2 paper. Question number 8. A tennis ball has a mass of 57 grams. A tennis player hits the tennis ball with a tennis racket. The tennis ball has a velocity of 25 meters per second when it hits the racket. The velocity of the tennis ball when it leaves the player's racket is 15 meters per second in the opposite direction from its approaching direction. So the average force exerted by the tennis racket on the ball is 35 Newton. And for how long is the tennis ball in contact with the tennis racket? Okay, so when the ball is coming towards the racket, suppose it is negative, and when it is going away from the racket, then it is positive. And the resultant force is 35 Newton. So what we will do? You know, the F is equals to the change in momentum divided by T. Now the T is the question. Okay. Now very simple. You see, F is equals to M1 V1 minus M1 U1, whole thing divided by T. So F multiplied T is equals to M1 V1 minus M1 U1. So the F will go on the other side. It will divide there. So the T will be equals to M1 V1 minus M1 U1 divided by F. So it will be 0.057 multiplied 15. I've converted that grams into kg, minus 0.057 into minus 25, and the whole thing divided by 35. So you will have 0.855 plus 1.425, and the whole thing divided by 35, that is 2.28, and divided by 35, and that is 0.0651 second. 0.0651 second. 0.06. So we think that 0.065 seconds. So it looks C is the option, sir. Question number 8, C is the right option, sir. Object X, this is May, June 2021, 2-3 paper, question number 8. Object X moves to the right along a frictionless surface towards a stationary object Y as shown. They make a noise as they collide, and then both objects moves to the right. Which equation is correct? Change in the momentum of the X is equal to the change in the momentum of the Y. Impulse of the force acting on X is equal to the impulse of the force acting on Y. Kinetic energy of the X before the collision is equal to the kinetic energy of the X plus the kinetic energy of the Y after the collision. And the momentum of the X before collision is equal to the momentum of the X plus the momentum of the Y after the collision. This is correct. Actually, the equation is that the momentum before the collision, and that is equal to the momentum after the collision. Because the Y is initially at rest, so its momentum will be 0. So that's why he has written that momentum of the X before the collision, because the momentum of the Y before the collision is 0. So that's why he skipped it. And that will be equal to the momentum of the X plus the momentum of the Y after the collision. So I think D is the best statement here. It looks to me D. Question number 8, D is the right answer, sir. So now we have May, June 2022 2-1 paper. He says 3 situations are listed. An object has a resultant force acting on it. A moving object experiences an impulse. An object is decelerating. In which situation is the momentum of the object changing? You see, when there's a resultant force, when there's an impulse acting, or the object is decelerating, these all things means that the momentum is there. So these all represents when the momentum change takes place, these all things happen. So I think question number 9D is the right option, sir. Question number 9, you can see D is the right option. May, June 2022 2-1 paper, question number 10. A ball of mass 0.16 kg is moving forward at a speed of 0.50 meter per second. A second ball of mass 0.1 kg is stationary. The first ball strikes the second ball moves forwards at a speed of 0.50 meter per second. What is the speed of the first ball after the collision? You see the momentum of the system before the collision is equal to the momentum of the system after the collision. So M1 U1 plus M2 U2 will be equals to M1 V1 plus M2 V2. It will be 0.16 into 0.50 plus 0.10 into 0 equals to 0.16 into V1 plus 0.10 into 0.50. So it will be 0.08 plus 0 equals to V1 into 0.16 plus 0.05. So the you will have 0.08 minus 0.05 equals to 0.16 V1. So V1 will be equals to the final velocity of the object 1. That will be 0.03 divided by 0.16, which will be 0.1875, which will be approximately 0.19 meter per second. 0.19 meter per second. So I think B is the option. Question number 10, B is the right option, sir. This is the solution, and this is the question. May-June 2022 2 paper, question number 9. Which statement describes the impulse acting on an object? Impulse is equals to the change in the momentum of the object. So I think B is the right option, sir. Impulse is the change in momentum of the object. Question number 9, B is the option. Question number 9, you can see B is the option. So May-June 2022 2 paper, and he says a ball of mass 0.1 kg is moving to forward at a speed of 0.50 meter per second. The second ball of mass 0.10 kg is stationary. The first ball strikes the second ball. The second ball moves forward at a speed of 0.50 meter per second. What is the speed of the first ball after the? It's the same question which we just did. And because this is the different variant, so, and the same question is given there. We have done this, so you can find out the solution. My final answer will be 0.19 meter per second. So I think question number 10, B is the right option, sir. Question number 10, B is the right option. Okay. So May-June 2022 2-3 paper, question number 9, he says, which equation for impulse is correct? Impulse is change in momentum, or impulse is equals to the force multiply time. So I think this is the right option, sir. Question number 9, A is the option. Let's check. Question number 9, A is the right option, sir. May-June 2022 2-3 paper, question number 10. He says a ball of mass 0.16 kg is moving forwards at a speed of 0.50 meter per second. A second ball of mass 0.10 kg is stationary. The first ball strikes the second ball. The second ball moves forwards at a speed of 0.50 meter. What is the speed of the first ball after the collision? You see the momentum before the collision is equals to the momentum after the collision. This is the same question again. This question came all the three variants of 2022. The question is still the same. Answer is B. I have explained it in the variant 2-1. Okay, B is the options. Okay, now we have October, November 2018 2-1 paper. Question number 6, he says a resultant force of 4 Newton acts on an object of mass 0.50 kg for 3 seconds. What is the change in the velocity caused by this force? Okay, we know the resultant force, we know the mass of the object, we know the the time for which the force acts on that body. What is the change in the velocity caused by this force? You know, the resultant force is equal to the change in the momentum divided by the time. So F is equal to the change in the momentum divided by time. So the change in the momentum is equal to F multiplied T. And change in momentum means M1 V1 minus M1 U1. So you can take M1 common, the mass is of the same object. So the M1 into the change in the velocity. So F is 4 and time is 3 and the M1 is 0.50 kg and into the change in the velocity. Now the change in the velocity will be equals to 12 divided by 0.50 and that will be 24 meter per second. 24 meter per second. D, question number 6, D is the option. Question number 6, you can see the D is the right option, sir. October, November 2018 to one paper, question number 8. A moving ball with a momentum of 25 kg meter per second collides head-on with a wall. It rebounds from the wall with the same speed but in opposite direction. The time of collision is 50 milliseconds. What is the average force exerted on the wall by the ball during the collision? You see, the resultant force is equal to the change in the momentum divided by time. So it is P2 minus P1, and he has told in the question that when the ball was going towards the wall, its momentum was 25 kg meter per second. And he says the momentum remains the same, only the direction of momentum changes. So when you rebound from the wall, suppose that is positive, and when you are going towards the wall, that is negative. So it will be the P2 minus P1, 25 minus 25 divided by 50 millisecond means 50 expo minus 3. So now you will have 50 divided by 50 expo minus 3, and that the answer will be 1000 Newton. So that means the resultant force is 1000 Newton. The resultant force is 1000 Newton. So that means that the answer is D. So D is the right answer. Okay, now we have October, November 2018 to paper, question number 8. An object of mass 3 kg traveling at a speed of 6 millimeter per second collides with an object of mass 2 kg traveling in the opposite direction at a speed of 2 meter per second. The objects stick together during the collision. What is the speed and direction of the combined mass after the collision? So the momentum before the collision is equal to the momentum after the collision. If you will suppose this is positive, if you suppose this is positive, then this will be negative. If you suppose this is negative, then this will be positive. So, okay. So the momentum before the collision is equal to the momentum after the collision. So it will be m1 u1 plus m2 u2 is equals to m1 m2 into v when they stick together. Okay. So that will be 3 into 6 plus 2 into minus 2. Why I'm putting minus 2? On the diagram I explained to you. That will be equals to 3 plus 2, that is 5 kg, and into the v. So you will have 18 minus 4 equals to 5v. So that will be 14 equals to 5v. So v will be equals to 14 by 5. That is 2.8 meter per second. And because its value is positive, so it is going to the right. Because I suppose when the ball was going to the ball which was going to the right, it has a positive velocity. So because the 2.8 is positive, so that means this will be going towards the right. So 2.8 towards the right. So we think that the D is the right option, sir. Question number 8, D is the right option. Question number 8, D is the right option. October, November 2018 2-3 paper, question number 6. An object accelerates from 10 meter per second to 30 meter per second in 4 seconds. The accelerating force is 150 Newton. What is the mass of the object? Okay. So the F is equal to the change in the momentum divided by time. Simply we can find out. So F is equals to m v1 minus m u1 divided by the t. So that will be 150 is the resultant force, that is equals to m into 30 minus m into 10, the whole thing divided by 4. So that will be 4 will multiply with the 150, that will become 600. And you will have 20 m. So m will be equals to 60 divided by 20. And that 60 divided by 2, sorry. And that will be 30 kg. So the mass of the object is 30 kg. The mass of the object is 30 kg. So that means D is the option. Question number 6. D is the right option, sir. Now, October, November 2018, 2-3 paper. He says an electron is moving at a speed of 5 expo 6 meter per second. A neutron is moving at a speed of 5 expo 4 meter per second. The mass of the electron is m. The mass of the neutron is 2000 m. So the neutron has more mass. Which row is correct? Greater momentum. Whether the electron will have the greater momentum and which one has the greater kinetic energy, electron or the neutron. So let me show you. Okay. So here you can see electron. First of all, I'm going to calculate the momentum for both electron and neutron. The momentum of the electron will be m into 5 expo 6. So this will be 5m expo 6. And the momentum of the neutron, that will be 2000 m into 5 expo 4. So that will be 2 expo 3 multiply m x multiply 5 expo 4. So that will be m expo 8. M expo 8. So I think because the power here, you see how you compare them, because it has larger 10 raised to power. The power of the 10 is greater here, so the momentum of the neutron is greater. Momentum of the neutron is greater. Now let's check the kinetic energy. So the kinetic energy will be equals to 1 by 2 mv square. So 1 by 2 into m into 5 expo 6 whole square. That will be 1 by 2 into m into 25 into 10 raised to power 12. So it will be 12.5 m expo 12. So it will be 1.25 m expo 13 joules. In the same way, you can calculate the kinetic energy for the neutron. That will be equals to 1 by 2 into 2000 m into 5 expo 4 whole square. So that will be 1000 m into 25 expo 8. And that will be 25 m expo 11. And that will be 2.5 m expo 12. So because this here, the power is greater. So that means the kinetic energy of the electron is greater, basically. The kinetic energy of the electron is greater. So the momentum of the neutron is greater and the kinetic energy of the electron is greater. So the greater momentum, it will be the greater momentum, it will be who? Neutron. The greater momentum will be neutron, and the greater kinetic energy will be electron. So I think C is the option. Question number 8. It's a very tricky question. Question number 8. C is the right option. A very tricky calculation. Okay, we have October, November 2019 2-1 paper. Question number 9. Two objects X and Y move directly towards each other. The objects have the same mass. Object X has a velocity of 5 meter per second, and the object Y has a velocity of 3 meter per second. Suppose if this is positive, then this velocity will be taken as the negative. Okay. Object X and object Y collide and stick together. What is their velocity after the collision? So remember the momentum before the collision and momentum after the collision, they are same. So mu1 plus mu2 is equals to m plus m into v. So m into 5 plus m into minus 3, and that will be equals to 2mv, because the 3, why we put a negative sign with the 3, because this velocity is opposite to the 5 meter per second velocity, which was towards the right. So you will have 2m is equals to 2mv, and so you will have v equals to 1 meter per second. So they will move at 1 meter per second because our answer is positive. So that means they both will go to the right. So I think B is the right option. Question number 9, B is the right option. Now we have October, November 2019 2 paper. Question number 9, a ball is at rest on the ground. A boy kicks the ball. The boy's boot is in contact with the ball for 0.040 seconds. The average force on the ball is 200 Newton. The ball leaves the boy's boot with a velocity speed of 20 meter per second. Which row gives the impulse of the boot on the ball and the average acceleration of the ball? So you see, impulse is equal to the change in the momentum, and the average acceleration of the ball we can calculate. So impulse is equals to the force into the time. So 200 Newton force is applied for 0.040 second. So the impulse is 8 Newton per second. Then we have the impulse is equals to the change in the momentum, that is equals to mv minus mu. 8 is equals to m into 20 minus m into 0. So you will have 8 divided by m is equals to 8 divided by 20 is equals to m. So m will be equals to 4 by 10. So that will be 0.4 kg. Now I can apply the Newton's second law. And that says F is equals to ma. So 200 is equals to 0.4 into a. So the a will be equals to 200 divided by 0.4, and that will be 500 meter per second. 500 meter per second square, sorry, acceleration this is. So the impulse is 8, and the average acceleration is 500. B is the option. Question number 9, B is the right option, sir. October, November 2019 2 paper. Question number 10, he says an object P of the mass 80 gram collides with another object Q of the mass 40 gram. After the collision, P and Q stick together and then travel on together. Before the collision, P is traveling at a speed of 6 meters per second and Q is at rest. What is the speed of the P and the Q after the collision? Okay. So the momentum before the collision and momentum after the collision, they are equal to each other. So it will be 0.080. I have converted into kg. Into 6 plus 0.040 into 0 is equals to 0.080 plus 0.040 into V. So you will have 0.48 plus 0 is equals to 0.12 V. So V will be equals to 0.48 divided by 0.12, and that will be 4 meter per second. So we have this C choice. Question number 10, C is the right option. Yes. October, November 2019 2-3 paper. Question number 9. The momentum of a body is changed by a force acting on it for a period of time. When the action increases the change, which action increases the change in the momentum? Doubling the force and halving the time? No. You know the change in the momentum is equals to the F into T. Is a repeat question, okay? So doubling the force for the same time, yeah, this is the answer. F multiplied T is equal to the change in the momentum. So if you will double the force and keep the time same, then the momentum, the change in the momentum will also become double. Question number 9B is the option, sir. Question number 9B is the right option. Here we have October, November 2019, 2-3 paper, a toy train P. This is question number 10. A toy train P of mass 0.50 kg is traveling along a straight track with a velocity of 3 meters per second. It collides with the stationary train Q of the mass 1 kg. The two trains then stick together. Okay. What is the velocity of the combined train? You see the change in the momentum before the collision and the change in momentum after the collision, they are equal to each other. So the M1 U1 plus M2 U2 is equals to M1 M2 into V. So you will have 0.5 multiplied 3 plus 1 into 0 is equals to 0.5 plus 1 into V. So you will have 1.5 is equals to 1.5 volts. So 1.5 divided by 1.5. So V value will be 1 meter per second. Question number 10. 1 meter per second. Question number 10A is the right option, sir. October, November 2022 one paper. A car is traveling at a velocity of 2 meters per second. It accelerates at a constant 0.20 meter per second square for 2.5 minutes. What is the final velocity of the car? Okay. So, acceleration is equals to V minus U divided by T. And V is equals to, this is the first equation of motion. And you get it from the formula of the acceleration. So V will be equals to U plus AT. So V will be equals to 2 plus 0.2 into 150. So V will be equals to 2 plus 30. So V will be 32 meter per second. 32 meter per second. You see, the time was given 2.5 minutes. So I converted it to seconds. That is 150 seconds. $32. Question number 3D is the option. D is the right option, sir. October, November 2022, one paper, question number 9. An object with a mass of 0.20 kg moves at a 0.20 meter per second as shown in the figure. You see the direction of the momentum is in this direction. Momentum can be found by just multiplying these two numbers. So which other object has a momentum that is identical to the momentum of this object? You see, this is in the upward direction. This is in the downward direction. This is towards the right. This is to the left. So this might have the same answer. Multiply here mass and velocity. Multiply here mass and velocity. And the direction also is important. You see, the momentum is equals to the m into v. That's 0.20 multiply 0.20. And that will be 0.04. Now, if you find the momentum of all the individual cases, in each case, the mass is given the direction of the. So, I have calculated the momentum for each case, and the same momentum is here in the C option. Question number 9, C is the option. Question number 9C is the option. The question number 9C is the option. We have the next question that is from October, November 2022 to paper. He says, a footballer kicks a stationary ball. His foot is in the contact with the ball for 0.050 seconds. The mass of the ball is 0.40 kg. The speed of the projection of the ball is 25 meters per second. What is the average force exerted on the ball by this foot? Okay. So F is equals to the change in the momentum divided by time. So it is F equals to 0.40 multiplied 25 minus 0.40 into 0 and the whole thing divided by 0.050. So the F will be equals to 10 divided by 0.050. So the F will be equals to 200 Newton. F will be 200 Newton. So question number 9C is the right option. October, November 2022 3 paper, he says, question number 9. A ball of the mass m falls vertically and hits a hard surface. Its speed on hitting the surface is v1. It rebounds vertically towards upwards with the speed of the v2. What is the change in the momentum of the ball? The change in the momentum of the What is the change in the momentum of the ball? That is equals to Suppose this is negative, suppose this is positive. Okay. So the change in the momentum will be mv2 minus mv1. So the mv2 minus m into minus v1, because they have the opposite direction. That's why we have put negative with the v1. And mv2 plus mv1, and that will be m can be taken as common. So the change in momentum will be equals to m bracket v2 plus v1, the total mass. So I think C is the option, sir. Yes, question number 9, C is the right answer, sir. October, November 2021 to 1 paper, and we are doing question number 7. He says, what is the relationship between the impulse acting on an object and the change in the momentum of the object? Impulse is equals to the change in the momentum. So I think A is the option. Question number 7, A is the right choice. So here we have October, November 2021 to paper. He says, question number 7. A rocket is launched upwards from the surface of the moon. Hot gases are ejected downwards over a very short period of time. Which statement is not correct? Which statement is not correct? A, the rocket experiences a downward force. The rocket will have weight, so that will be equal in the downward direction. So it is right. So this is right. The rocket experiences an upward force. That is also right. The total momentum of the hot gases is equals to the total momentum of the rocket. The momentum of both these things is magnitude is equals, but their direction is opposite. The total momentum of the hot gases and the rocket when the hot gases have been ejected is 0. That is the true statement. So what is the wrong statement? This one is the wrong statement. Their momentums are not equal to each other. Question number 7, C is the right answer. October, November 2021, 2-3 paper. Question number 7. A cricket ball has a mass of 0.16 kg. The ball travels at 30 meter per second. The ball is hit by a bat with the force of 10800 Newton. After being hit, the ball moves off with a velocity of 30 meter per second in the opposite direction. So if this is positive, then this is negative. Okay. So for how long was the ball in contact with the bat? We have to tell the time. Okay. So F is equals to mv minus mu divided by t. So 10800 is equals to 0.16 into 30. That's the final velocity. Minus 0.16 into minus 30. And the whole thing divided by t. So you will have 10800 t is equals to 9.6. So the t will be equals to 9.6 divided by 10800. So that is 0.000888. So it is 0.00089. So let's check. B is the right option, sir. Now we have October, November 2022 2-1 paper. Question number 9. An object has kinetic energy of 200 joules. A constant resultant force of 190 Newton is applied in the direction of its motion through a distance of 10 meters. What is the final kinetic energy of the object? The work done is equals to the change in the kinetic energy. Okay, so here we have the kinetic energy. First, the kinetic energy is 200 joules. Now you have done work on it, and you have applied the force in the same direction. So the work done will be equals to force into distance, 190 Newton force into the 10-meter distance. So you will have 1900 joules. So the total kinetic energy of that system after the application of this force will be 200 joules plus 1900 joules. So you will have 2100 joules, 2100 joules, 2100 joules. D is the right option, sir. October, November 2022 2-2 paper. Question number 7. He says, a trolley of mass 4 kg traveling with a velocity of 4 meter per second collides with the trolley of mass 2 kg traveling with a velocity of 2 meter per second in the same direction. Okay. After the collision, the velocity of the 4 kg trolley is reduced to 3 meter per second. What is the velocity v of the 2 kg trolley after the collision? So the momentum before the collision is equal to the momentum after the collision. So m1 u1 plus m2 u2 will be equal to m1 v1 plus m2 v2. So you will have 4 into 4 plus 2 into 2, and that is equal to 4 into 3 plus 2 into v. So that is 16 plus 4 is equals to 12 plus 2v. 20 minus 12 is equals to 2v. So you will have 8 divided by 2, and that will be 4. So the v is 4 meter per second. The v is 4 meter per second. October, November 2022, 2-3 paper. Question number 7. A force F acts on a body of mass m for a time t. During this time, the velocity of the body increases from u to v. Which equation relates F, m, t, u, and v is the famous equation that the F is equals to uh, change in the momentum divided by t, or you can say Ft is equals to the change in the momentum, or Ft is equals to m bracket v minus u bracket close divided. I think C is the right option. Question number. So I just yeah, here we go. A force F acts on a body of mass m during this time the velocity increases. Okay, so they have the same direction. I think C choice. C is the choice. So, my dear students, we are done with this worksheet, and we have done. Let me escape from it. So basically, there were in this video, we have done uh, from from 2018 to 2023, all the available questions. The paper 1 in IGCSE, they call it paper 2, and this is extended physics. And I have done video on this because I want my O-level students to prepare the MCQs of this new topic, because it will be assessed in this exam in May-June 2023 exam. So I hope that this video will help you. I have tried my best to collect the questions on momentum, impulse, and resultant force. And if you are watching this video, hopefully this video will help you. If you think this video has helped you, please like this video. Also share the link of this video with your teachers, with your class fellows, with your junior students, with your senior students. When you do this, this helps me to promote my channel. Thank you very much for watching this video. I think it's a great blessing for me that I can make these videos and I can share the link of these videos on my YouTube, and they can touch the life of so many students around the globe. Thank you very much. Have a good day. God bless you all.